Everywhere this magnetic field is present. No, it will deviate. So what can be the motion of charged particle? How do that motion occurs here? So it should be a part of a circle. It should be a part of a circle. Don't do like this, sir. I think it's wrong. Am I right? At least some common sense should be there. How the particle is having velocity v horizontally. So therefore, I have to bring the diagram in such a way that the velocity of particle entering the magnetic field will be horizontal. I think the diagram now will be justified. You must know your coordinate geometry. It's not possible. Sir, students are asking, sir, like they're drawing circle, some random circle. How the velocity of particle when entering magnetic field? It's horizontal. So that has to be taken care, no? No. Okay, this is the path here. So finally it will enter here. Circle will not be, what is the circle? Path of a particle, no, how it should, I should draw a tangent. There's a velocity of particle. Here, it will live like this. Oh, that one, you mean to say force one, B bar velocity. Okay, I'll do one thing. It should enter radially, no? Okay, I'll do one thing. I'll okay, the diagram. Yeah, I'll do one thing. Here it should enter radially. Yeah, okay, yeah. I'll take care of it. So it should be. Now instead of this, we'll show that it is entering here. Justified. It's now B bar velocity. Yeah. The particle when it arrives here, check it now. B bar is into the plane. Okay, let me take this as a O. B bar and velocity, the force will act towards center. So center of the circle is what needed. And finally it emerges out. Is asking that deviation. According to the question, I made it. Yeah. Let's get into the overall concept. So let's get into the how the force will act. The force should act towards the center of circular path. So the center of circular path will be here. Very difficult to. It should not be horizontal. See this. This will be the center of circle. Let radius of the magnetic field radius of the magnetic field region is R. Radius of this, let it be small r. This O. So one reference line will draw it. Yes, now we can get into the concept. So there's a deviation, theta. Hope everyone is able to get into the thing. So let me define few terms. So let me call this as Y. This length as Y, this length as Y. Can we define all the quantities? Sin theta, I'll define Y by R. Then what is Y, all those things we have to explain things. So if this is theta, this will be theta. and this distance is r. Okay, look at, we have several triangles here. In the triangle, it will enter at A, it will leave at B. Now take help of this triangle. We have to get that theta in terms of known. What are the known things? Capital R, small r, and the motion of charge particle, mv, all those things are given for us. So what is small r? Small r is mv by qb, is what we are assuming it. The radius of circular path of the charge particle will be inside the magnetic field, not outside. It will not move in circular path. Only when it is there inside the magnetic field, it's going to move in a part of a circle. Let it be here. So first we'll write it cos theta equal to y by r. Sin theta is equal to y by small r. What is small r? mv by qb. So this will become qb by mv. So this is the sin theta. In term, what is y equal to? Capital R cos theta. qb by, so this is sin theta. Okay, tan theta is equal to r qbr mv. What is the deviation? Deviation is, total deviation is delta equal to 2 theta. So this will become 2 tan inverse of qbr by mv. Find the deviation in the path of the charge particle. I'll ask you, what is the time spent? What to write? Time spent. Time spent by charge particle in magnetic field. This should be equal to theta. This should be, shall I write deviation by omega? Deviation we know. There's another thing. The deviation is given by 2 tan inverse of qbr by mv qbr by mv. Then omega will become bq by m. So this will become 2m by bq tan inverse of this is a time spent. So different types of different shaped fields come. So, so you should be in a better position to analyze that the path of a charge particle in magnetic field will be a part of a circle. This is something very, very essential. I'll take the next question. We'll take this one.